So we want to work on our baseball problem. It says it gives us a table with a baseball of height in feet and then distance from the player x in feet. So the first thing we want to do is put this data into our graphing calculator in our spreadsheet. So we can go to the home screen and we're going to go to new document. What you want to do is add in a list and a spreadsheet. You're going to name A, this top column, X, and B, you're going to name it Y. Once you have everything named, then you can fill in your X chart with the X data. So 2, 3, 4, you're going to fill in this chart in your spreadsheet. Okay. So now you've got the X data in, and you can put in now your Y data. Okay. With all of your Y data in there, now what you want to do is write the model to present this data. So we're going to have the calculator do that. To make the calculator do that, you're going to go to Menu and Option for Statistics. Once you get into Statistics, you're going to see Stat Calculation, and then you're going to choose Quadratic Regression. That's Option 6. So go to Quadratic Regression. It's asking you right now, where did you put your X variable? And we put it in the column that we called X. Where did you put your Y data? In the column that we just called Y. It's going to name your graph F1, and that's great. And then it's going to put all of your data into column C. As long as this isn't A or B, you should be fine. Hit OK, and there's all of your data that comes up. So we've got a quadratic regression, and it's telling you all of your info. What I want you to do, though, is to go to Document, and I want you to insert, that's Option 4, a graph. You want to insert a graph. Remember that we told the calculator to label our graph F1, and we're at graph F2. So to go to graph F1, you're going to push the up arrow once, and there's all of your data. Now you can hit enter, and you can see the path of the baseball starting from the batter all the way up and into the ground, where it lands on the ground. This equation is the answer to part A, but I can't really see all of it. So I'm going to take my trackpad, and I'm going to get my hands. Once my hands comes over the letter, I'm going to click and hold the center button, and then my hand will close. Now that my hand closes, I can move my equation off to the side and see the full equation. Now it's time to write this equation into my part A response. So h at x is what they asked me to name this, equals negative 0.125 x squared plus 1.250x plus 0.875. Alright, so there's my equation. And they want me to evaluate when the height is 0, so when x is 0. To do that, I can press the blue control button, and the table button, the T at the bottom. That will bring up my table, and I can then go to where x is 0. When x is 0, y is 0.875. So we're going to put that for part B, 0.875. Now we need to interpret this in the context of this problem. So we're going to use the units for x and y in our chart to evaluate and interpret. So 0. 0 is in the x position, so I'm going to use the x units. At 0 feet, the baseball is 0.0875 feet high. There's a bunch of ways to say this, but this for sure indicates that we understand the x number and its relation to the x unit, and the y number and the y unit. Part C, what is the maximum height of the ball? I'm going to make my table go away, so I'm going to press Control T again, and my table will go away. I can press Menu, Analyze Graph, and find the maximum point for this graph by clicking to the right, to the left and to the right of the maximum. This happens at 5, 4. So I'm going to write 5, 4 as my coordinate point. And it's asking me for the maximum height of the ball. Height is a y variable, so I just need to look. The maximum height happens at 4 feet. At 4 feet. Alright, how long before the ball hits the ground? When does the ball hit the ground? When the ball hits the ground, we'd expect the graph to actually intersect the x-axis. Again, I can't really see that. So I'm going to track over to just a blank area in my calculator screen and click and hold the center button. You see how it now grabs my screen? And I'm going to just track over to the left side. It's going to shift my whole graph over, and now I have a much better picture of what's going on with my baseball. In the real world, I'm not going to see any of this, because that would mean that the baseball went into the ground and is now tunneling under the ground. And hopefully that's not going on. In the real world, our baseball would hit the ground right here. So let's find that point. We're going to hit Menu, go to Analyze Graph, and then find the 0, option 1 here. Find the 0. Click to the left and to the right of that intersection point, and then you're going to see that that coordinate point come up. That is 10.657, 0. So we write that down, 10.657, 0. And this, the ball hits the ground at 10.657 feet from the player. Okay. What is the domain and range from this situation? I'm going to go ahead and set up my domain and my range. The smallest possible x number, the smallest possible x value that I could have in the real world starts right here when x is 0. Okay? And then the biggest possible x number I could have happens right here at 10.675. That's my domain. I go from the smallest number that x could be on the x-axis, and I'll go all the way up to the biggest. And then my range does the same thing. The smallest possible y value I could have is right here at 0. That's the smallest y value. It's not up here. It's down here at 0. And then the biggest y value I have is when y is at its maximum at 4. So those are all of the numbers that I want to include in my domain and range. My domain, again, we said was going to be start at 0, and it was going to go all the way up to where the ball hits the ground at 10.657. And then my range, the smallest range was 0, and the biggest value that it could take on was 4 feet high. So there's domain and range. It's going to ask me how far away will the ball be at a height of 3.456 feet. So height of this is a y variable. In other words, they want me to substitute in on the y side. So I'm going to go back into my equation, and because this is going in on the y side, it's going to be opposite, right? So I need to not add 3.456 to this equation, but I want to subtract 3.456. So at the very end of my equation here, now that I've got that up, I'm going to put in minus 3.456. And hopefully what will happen is it's going to recalculate a 0 for me. And there it is. It's going to go all the way down. It's going to shift down by that amount. And I can recalculate my zeros. So menu, analyze graph, and then find your 0. Your 0 happens right here at 2.914. So x equals 2.914 feet. And I see that I've got 2 of them, so I'm going to write my other 0. Go to menu, analyze the graph, get that 0, come right here, and there's my other 0 at 7.086 feet. And you want to make sure that you have your units on there too. So what is the average rate of change of the height of the baseball over the interval 2.5 to 6.75 feet? So to do that, we want to go back to our equation here. I can go and I can put my finger on this line. When I do that, it will turn bold and I can double click. Once that happens, my equation pops up. And then what I can do is come back in and I can take off that minus 3.456 that I put in earlier. So all of this at the very end, 3.456, all of that's going to get deleted off. And I'm going to go back to my original equation. And I want to find those 2 points. One at 2.5 and then one coordinate point at 6.75. Once I get the 2 coordinate points, I can find the rate of change. Another word for this rate of change is going to be slope. So I'm going to find the slope using these 2 coordinate points. Okay? So go to Document, Insert, and then you want to insert a calculator. Remember that earlier when we did our regression, we named this graph f of 1. So you want to name your graph f of 1 again, and then they ask us to evaluate 2.5. So that's the coordinate point 2.5, 3.21875. So 2.5, 3.21875. That's your first coordinate point there. They also want us to evaluate not just 2.5, but also 6.75. So now we'll go back to our original function. Then we will type in f1 at 6.75. It comes out with 3.617. 3.617. So 6.75, 3.617. I'm going to round this to 3 decimals, so this is going to be 219, and 875 can go away. And now I have my 2 coordinate points. To find the slope, I just need to use my slope formula, and that's y2 minus y1 over x2 minus x1. Once we do that, we fill in y2 minus y1 over x2 minus x1, which looks like this. And I simplify. So 3.617 minus 3.219 is going to give you 0.398. And then your 6.75 minus 2.5 gives you the 4.25. I use my calculator, divide, and you're going to get 0.0936 or 0.094. So your final answer, the baseball travels 0.094 feet, height in feet per distance in feet. 0.094. And that will be your rate of change.